Right guys, let's give this a go. We're doing some recorded shoots. We're looking at our combinations review right now. I'm doing 1.8 review exam practice. In the room with us we have Indiana and Nigel answering questions from the field. Just those looks that they gave me is all worth it. All right guys, hopefully you can see this. I'm just trialing it out. If it doesn't work, come to Toots. Don't know what to tell you. Let's go, question one. Inclusion, exclusion principle. Okay, so this is one of the first things that we learn in our combinations, and you guys think about the word inclusion, exclusion. What are we going to include? What are we going to exclude when we have three sets, R, S, and T? If you need a little help.
I was thinking about chemistry. I said fully exclusion principle.
Inclusion, exclusion, so you want to be thinking about your unions and your intersections.
This is in diagram stuff.
Yeah, you don't need to draw a diagram. We have a rule for this, the inclusion, exclusion rule. We learnt 4 in Unit 1. Permutations, combinations, multiplication, and the inclusion, exclusion rule.
Pascal's triangle.
The union of R, S, T is equal to the number of R plus the number of S plus the number of T minus RS minus RT minus TS plus RST. So if you remember your Venn diagrams, you add up each of your 3 sets, you subtract the intersection of the 3 different ones, and then you add back in the intersection of all 3 to make sure that you are not double dipping. And so that's your rule. Add them individually, subtract the intersection of 2 sets, add back in the intersection of 3. You know this?
Yes.
You remember this?
Yes, because it was stupid, like, Venn diagram.
Let's see if that makes it any better for you guys to see. Inclusion, 52 cards that are either red or jack, a court, or a king. All right, so let's say that R's going to be my reds. What's the number of R? How many red cards in a deck of cards? 26. How many jacks are there?
4.
How many court cards are there?
What's the court cards?
They're king, queens, or
king,
jacks.
It says it on the map. 12.
12. 4 sets, 3 in each. Inclusion, exclusion principle. So we have, what are we doing here? The union of R, J and C is equal to plus 4 plus 12 minus, now I haven't set these up, but how many red jacks are there?
2.
How many red court cards are there?
6.
No.
How many jacks are in the court cards?
4.
Was that 2?
She was right, 4.
I thought it was.
How many jacks are in the court card? All 4 of them. The 2 red and the 2 black cards for the jacks. How many red jacks are courts?
Red jacks or court?
2.
2. Add those back in.
So you can cancel that out. So what's that? 40, 42.
Who's got the fastest mental arithmetic?
Oh, 30, 42, 32.
32. Good thing to be able to do. Some estimation. Did you get that right? This is the inclusion of all cards that are red, or jacks, or court cards. The red cards contain everything that's red, including 2 jacks and 6 of your court cards. You've got 2 black jacks that are also in the other 6 of your court cards. So you've basically got your 26 reds plus the 6 black court cards. Get you 32. Yep, so I think we've got that one correct. Moving on to state the multiplication principle. Sorry, I wrote that as 2. It should be 2A. State the multiplication principle. Multiplication principle. Who can remember? Two blues now. One for upstairs, one for downstairs. Different locks.
Thank you. If it's R and S ends here, then it's R times S times 2.
Let's go A.
Hello.
If there are n ways to make A and m ways to make B, there are n times m ways. So, look, I'm not going to ask you for definitions on the exam. This is just your multiplication. You know that when you're collecting 2, distinct groups and you want to find out how many ways you can sort them out together, you're multiplying. So that's really, and it's in the name, the multiplication principle. So you've got 2 sets of things. You want to know how many different ways you can combine them. You don't add them, you don't divide them, you don't subtract them, you don't do anything else. You just multiply them. That's all we need. B. 1 or 2 letters are to be chosen from the letters A, B, C, D, E, F. In how many different ways can this be done without replacement? Let's have a look at 2. Now you guys may want to jump to your permutations, but I can tell you just from the way that this review set's being organised that you don't need to do that just yet because you've got relatively low numbers. So first of all, we're doing A, B, C, D, E, F, A, B, C, D, E, F. So we are looking at 6 things. And we're trying to determine, choose 1 or 2. So let's take care of the 1 first. How many different ways can you select one thing from 6 things? 6. One thing. How many different ways can you select 2 things from 6?
12.
Alright, so
One thing.
If there are 6 ways to choose the first letter, there are 5 ways to choose the second letter, there are 30 ways to choose 2 things from 6 things.
Oh,
Yeah?
because it's not replacing. So
Yeah, you're not replacing in order that's important. So they're distinct letters, A, B, C, D, E, and F. We don't have any duplicates. And once the first thing's taken out, that means we have 5 other things we can select.
So if replacement.
If order is important is in this question. It does say order is important, which is why we're doing our 5 followed by 6. And there is definitely no replacement going on. Yeah. Yeah. How many different ways can this be done without replacement if order is important? So we're going to follow this. So ways of selecting 1 or 2 equals 6 plus 30 equals 36. and find a pen that can actually be seen. Oh, that red's pretty good. Let's try that for the next question. Oh, we've broken Indy. Question 3. Finish the rule. NPR equals.
N factorial over R factorial, open bracket, N minus R, close bracket, factorial. Is that all you have to do?
Isn't that combination? That's C.
Yep. That's the combination rule.
Yeah, but it says state the definition of NPR.
Yeah, and that's not the right rule.
So we both gave the wrong rule.
No, you gave
NPR.
No, you were saying the same thing.
N factorial over R factorial.
Good try. Yeah. N minus R on the bottom for your permutations, N minus R and R factorial for your combinations.
So then I can see, okay, how have you moved from sleepy's being unconscious or whatever, to
This is really frustrating because this was a brand new marker yesterday and it was writing real
the
nice.
first paragraph is generally where you describe the event to practical or the original experiment that you're modifying. So what was it? What did you investigate?
Again, you'll be given these rules, and it's a fairly common mistake to get your C and your P confused, but yeah. However, Indy, yes, your rule is not. There's no such thing as N factorial over R factorial, as far as I'm concerned. There kind of almost technically is, but you'll see it in a sec.
You smell like hand sanitizer.
You'll see it in a
Because I
sec.
had hand sanitizer on.
But you don't smell like yogurt hand sanitizer. You smell like
Yeah, like so fine
cherry blossom hand sanitizer.
Okay, without a calculator, compute the value of
Easy, I can do that one for sure.
10p3. Well, now that you've got the right rule, you should be able to do it quite easily. And I'm just giving you guys a quick little head start because I'm still recording this, so the guys at home probably want to see. If they don't, they can always pause the video and have a go. This is going to equal 10 factorial divided by 10 minus 3 factorial. That equals 10 over 7. And remembering the easiest thing to do here, because you're asked to do it without a calculator, is you cancel every number from your denominator down, and so you're left with 10 times 9 times 8.
You got me confused.
This is where I would use the commutative rule to make my life easier. What's 9 times 8?
Oh, you can do 10 times 9.
72.
What's 9 times 8?
72.
Add a 0.
720.
If you wanted to do 10 times 9 to get 90, and then you wanted to do 90 times 8, you absolutely could. But if you ask me, 8 times 9 for 72, add a 0 is the easiest way to do it.
Well, you can also
I
do
like to
9
make my
times
maths life
10
difficult.
is 19, 19 times 8, take away the 0, 9 times 8, 70.
That's way more words than I just used. My way's definitely easier. Just saying, because they did ask you to do it without a calculator, I'm sure some people got some great mental arithmetic and can easily do that. I'm always trying to find ways to make things easier for myself.
Yeah.
Uh-oh.
720, what's the next one? Prove. Okay, this one's a bit annoying. And I don't think we're even going to focus on it, to be honest. The proof for this is simply what would you have on the left-hand side? So if we were proving that NPR is equal to n factorial divided by n minus r factorial.
Did we just do that as the rule?
No, but this one we're proving.
Yeah, so not
Or
really something.
proving
So,
that it equals. Sorry, I
because
thought it said
what are we
this
doing
way.
here? What you need to remember is your left-hand side then starts to look like this. This is n times n minus 1 times n minus 2 times
Yeah, and so when you're discussing any trends, so if you're comparing your means,
n minus r plus 1
this proof is this linear,
is what it gets to in the end.
higher even the standard deviation.
Oh, I remember looking at this.
This which shows more variability.
It was a pain in the butt.
Because I remember doing the x dot 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 dot.
Yeah. Oh, sorry, I forgot the last term, and then this is just n minus r is where it ends
So
up.
what you're going to do, right, is you've got to compartmentalize. So what you do is you
Minus
put
n minus r?
down to the pit of your stomach, and then you can fill the ice cream later. Right? You push it down
Oh no, that's where I'm getting confused. So that's your left-hand
all the way
side.
down, and then, you've got to go ahead
Um,
and do that later.
On your right hand side, your n factorial up top's going to be this one.
What we've got now is we've got into free, right?
No, sorry. N times n minus 1 times n minus 2
We did do it last term, look at me relating our
n minus r.
So, what we have to do,
That's what you should have on that one.
we're gonna take a breath, we're gonna think about something that we really love,
Think.
and that way we can move on from it. Okay, and then, okay, let's.
And this is why I don't really like this question. It doesn't serve as a whole bunch of points, and it's just a bunch of numbers. It's not actually going to help you with your understanding, but let's just go through all of our responses. And that needs to be divided by n minus r.
What is left? So tell me what.
Factorial. Because this is going forever as well. So,
Next, any other questions from the floor?
that's what we've got on this side, that's what we've got on the left side.
Is that what?
These guys cancel out. Your left equals your right. So again, it's not a particularly fun or interesting proof. I thought I'd just walk you through that one. Okay, here we go. Let's do a real question. Freestyle snowboarder competition has 15 entrants. How many ways can first, second, and third places be filled? You may wish to use technology.
Depends if Sean White's in it or not.
Depends if Mr. Laginus, first place, guaranteed every time.
Well, so that's Sean White. I'm 15, right? That's my spot.
Okay.
You can have that one for sure.
15 snowboarders. 3 places that they can take. Factorial 15 divided by 15 minus 3 factorial. 15 on 12. 15 by 14 by 13.
You can't cheap shop this one, sir. No calculator.
Yeah, no calculator.
No, this one you're allowed a calculator for.
We don't care. What if it's on a non-calculator exam?
I would never make you multiply 15 by 14 by 13 in your head. You could do it. You could do it on paper. It's a waste of your time. You guys are specialists. We're trying to teach you complicated things. There is no situation in the world where you'll be doing this kind of math without having a calculator in hand.
So I can then assume that we get to use our calculator in the exams for both.
Well, if anything, like that first one that we did, P103, I could give that to you and say you can't use your calculator. Because the numbers are so small. You had to do 10 times 9 times 8 at the end.
Yeah, but
Yeah.
for our exam,
2730.
For your exam, if it has a non-calculator section, the sums will be very easy. The process is what we'll be interested in. It will not be a test of how well you can multiply in your head.
well, are we having tech free or tech active?
I am making changes to the exam because of Rona. I'm trying to find any fat that I can and cut from it. I'm not sure that I will, which is why I'm being a bit cagey and vague at the moment, because I have not actually locked in exactly what you guys are going to need to do.
I just want to know if we do tech free or tech active.
You'll definitely have lots of tech active. If there's any tech free, it's to be undecided. Definitely tech active.
It's to be decided. Okay.
Yeah.
How
Be
long
right.
will the exam go?
It'll be 2 hours.
Just casually 2 hours for the tech active.
The whole thing.
Oh, whole thing.
Why is that twice as long as our other exams?
No method.
Question 5a. Suppose 5 people are to be seated. Explain why there are fewer ways of seating 5 people at a circular table compared with seating the group on a straight bench. Easiest way to answer this one is with some diagrams or just making up some arbitrary examples. 5a. So what I would say is that if you have a straight bench, A, B, C, D, E, and C, D, E, A, B would be 2 different combinations of those 5 people on a bench. A, B, C, D, E is no different to C, D, E, A, B as far as the circle is concerned. They still both go A, B, C, D, E, A, B, C, D, E. So when you arrange things in a circle, you do not have as many combinations because there is no defined start and finish point in your circle. So these 2 things are exactly the same. These 2 things are different.
So when B says how many ways can 5 people be seated at a round table, it's
There is
1, right?
Not quite. So, 4 questions in a round. 5 people. You would normally be able to select 5 people, factorial 5 ways. 5 by 4 by 3 by 2 by 1. In this case, for seated in a round, you must divide that by your n. Okay, we don't have a rule for seated around in a table. You just straight up apply your knowledge. That the number of factorials for the number of people you've got divided by those. So what that really equals then is factorial 4. Because it cancels the 5 out. So that's another way to think about it. When you are seating in your arrangements, you basically take a 1 off your n and then just get its factorial.
So 24.
Yep.
So I mean, we're doing these screenshots because it's the main thing that you need to do, but obviously
24 ways.
Yeah, but you're looking around.
you're gonna need to.
24 ways. Looks like we've got time for one more question.
Yeah.
Which is a good one, actually. Let's do this one. Yeah, excellent. Good question. So we are trying to arrange the words, or how many different ways can we arrange the words wool and gabba? I'll write it up. Can you guys spell it for me?
WOOLLOON GABA. So GABBA.
All good?
How many letters are there?
So
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
You
13.
Google it and you work it out.
N equals
How do
13.
you know everything that we know?
What's the trick with this kind of question? What do you remember?
Multiple letters of.
Very good.
I just asked you.
Yeah.
It's from the, and how do I find out? The
So we now need a list of all of our duplicates.
tip.
How you do it.
How many O's are there?
4.
How many L's?
2.
A's?
2.
B's?
2.
Any other duplicates? W and N only show up once. And G shows up once, yeah. So we're only concerned about our duplicates. Okay?
How would you use your inclusion, exclusion?
The process for this one, a little bit different to our round table where we just divided by our n. In this one, we take our n factorial divided by the number of each of our duplicates factorial.
Got it? Yeah, cool. Yeah, so here's that. So
Basically what you're doing is removing all the alternate ways that you could arrange these. Because what it means is that when you select that B, you've got 2 ways that you can select the same B. And it wouldn't look any different. So you're trying to remove each of these duplicates as you go down, basically. Because there's 4 of these, there's 4 times 3 times 2 ways that you've got to take them out because there's just that many duplicates. Question like this, I highly recommend you just go straight to your calculator. You punch in 3 factorial divided by 4 factorial, 2 factorial, 2 factorial, 2 factorial. I forgot my multiply signs.
13 factorial
They're
divided by
good.
12.
yeah, that's good. Have that.
Yeah, I guess that's the other way you could do it. Should have gotten a very large number, something like 3, 2, 4, 3, 2, 4, 0, 0.
I'm going to do the math. That's exactly what I got.
Yeah,
Okay, guys, and that is our intro to permutations as far as this review set is concerned. That is all your simple, familiar questions around permutations. Standard permutation, permutations in a circle, permutations with duplicate, non-unique members. These are 3 types of permutations you do. From here, we start talking about combinations in the question set, okay? So we'll pause it there. That's 4 o'clock.